but it is going to be useful. And it is looking at variables. So if I have x to the power of 6, x to the power of 6 is x times x times x times x times x 6 times. Or two groups of x times x to the power of 3. My exponent rules from last year, which you guys did in grade 9, if the bases are the same and I'm multiplying, I can add the exponents. So square root has an index of what? 2. When I'm calculating the square root, what I'm basically doing is asking what number times itself would give me x to the power of 6. Well, that would be x to the power of 3. 2x to the power of 3's would give me x to the power of 6. If I'm finding a cube root, then what I'm looking for is a number that when I multiply it by itself 3 times, I get that value. So x to the power of 15, I can look at it as being an x to the power of 5 times an x to the power of 5 times an x to the power of 5. So when I take the cubed root of it, I would get x to the power of 5. What do you notice about these two, or these three numbers? The 3, the 15, and the 5. The 2, the 6, and the 3.
You divide the power by the index.
If I divide the power by the index, I'm going to get the exponent on my answer. So if I wanted to take the square root of x to the power of 4, what would I get?
X to the power of 2.
If I wanted to take the square root of y to the power of 10, what would I get?
Y to the power of 5.
Thanks, Connor. If I wanted to take a to the power of 8, b to the power of 6, and I wanted to take the square root of that,
A to the power of 4 and B to the power of 6.
what about the cubed root of x to the power of 24?
X to the power of 8.
And the cubed root of y to the power of 6?
Y to the power of 2.
Okay. So then the next part, what happens if I can't divide it evenly? Because if I have x to the power of 5, 5 divided by 2 isn't an even number. Split it. I know that if it's a 2, I can divide any even number by 2. So I make this a 4 times x. X to the power of 4 times x is still going to give me x to the power of 5. But now I have the square root of x to the power of 4. What is the square root of x to the power of 4?
X to the power of 2.
And then I'll still have this x underneath the radical sign. So I can say that x to the power of 5 is the same thing as x squared times the square root of x. So if I have the square root of a to the power of 7,
A to the power of 3.
okay, so how did you get the 3 first? What did you do underneath the radical sign?
I split it.
To 6 and a.
Okay.
So then the square root of a to the power of 6?
It'd be A to the power of 3 times square root of
Right. So how would I split t to the power of 9?
T to the power of 8.
T to the power of 8 times t to the power of 1. I can use a dot for my multiplication symbol instead of an x. So what is the square root of t to the power of 8?
G to the power of 4.
So I get t to the power of 4 times the square root of t. Okay, c is a bit different because I have a cubed root. So if I have a cubed root, how would I split x to the power of 5 up?
X to the power of 3 is x to the power of 2.
because 3 I can divide by 3. So what would the cubed root of x to the power of 3 equal?
X times root x squared.
Root 3x squared.
So do you times that?
Or the cubed root.
Third, whatever.
Yeah.
I knew what you meant.
That answer.
It's perfect.
Okay. What would I do if it was x to the power of 7?
X to the power of 6.
The cubed root.
So I'd have x to the power of 6 because I can divide 6 by 3, and then the other x to give me to 7. And the cubed root of x to the power of 6, Kirsten. What would I do with the power in the index? And then the cubed root of x. So the next 2 sets of examples, the questions just become more. We increase the number of variables. We throw numbers in there as well. We just get crazy. So if I have the square root of x to the power of 6 and y to the power of 5.
Oh.
This is an index of 2, so I have to be able to divide everything by 2. Can I divide 5 by 2? No, what can I divide by 2? 4. So I change the y to a 4 and a 1. What is the square root of x to the power of 6?
X to the power of 3.
Kate, what would be the square root of y to the power of 4? And then the y that is remaining would stay underneath the radical sign because I can't square root just the y. Okay, in B, I have numbers and I have variables. So let's look at the number first. This is a square root. So can you think of a perfect square number, which are that column that's in the reds? Can you think of a number that I can divide evenly into 18? So I get 9 times 2. And then what do I need to do with my x cubes? I have to split it into x squared and x. And then I go through. Can I take the square root of 9? I get 3. Square root of x squared, I get x. And then I'm left with a 2x. The next one, 32. What perfect square number can I divide 32 by? 16. So 16 times 2. And then y to the power of 7 I have to split up into y to the power of 6, y to the power of 1, and then my z to the power of 8 I can leave. Because I'll be able to divide that by 2. So square root of 16. And the 2 is going to stay underneath the radical sign. Square root of y to the power of 6. Y to the power of 3. This y is going to stay underneath. And the square root of z to the power of 8. Z to the power of 4. Okay. D is an index of 3. So with 40, I have to think of a perfect cubed number. What can I divide 40 by? 8. So I get 8 times 5. X to the power of 4, I would split into 3 and 1. So x to the power of 3 and x. And do I need to split y to the power of 9? No, because I can divide 9 by 3. cubed root of 8 is 2. And then I'm going to put my cubed root over here because I can put the 5 underneath. Cubed root of x cubed. X to the power of 1. And then this x will stay underneath because I can't cube root that. Can I cube root y to the power of 9?
Y to the power of 3.
So I get 2xy cubed times the cubed root of 5x.
Get off.
So the last 4 go from a mixed to an entire. So that's putting everything underneath the radical sign. So if I have to put the 2 underneath the radical sign, what will I need to do to it? I need to square it. So what is 2 squared? So I will get 4x cubed, the square root of 4x cubed. If I look at B, to put that a squared underneath the radical sign, I have to square it. So if I have a squared raised to the power of 2,
It's actually a to the power of 4.
it's a to the power of 4. And then if I times that by a, what do I get?
A to the power of 5.
A to the power of 5. For C, the same thing. If I put x to the power of 5 underneath the radical sign, I need to square it. And what is x to the power of 5 squared? Not 7. 10, because it would mean 2 groups of x to the power of 5, right?
So you're just multiplying the.
Yeah, when there's brackets and you have
Just
the exponent
multiply
on
it
either
by
side,
2.
you multiply them.
Yes. So this you multiply, and your question was,
I was just getting confused because you were saying square and then you're.
well, it's x to the power of 5
Yeah.
squared.
Yeah, that,
which
I was
means-
just getting confused.
Multiply x to the power of 5 by itself twice. So how many x, or, sorry, not how many x's, x to the power of 11 times y.
But isn't xy like one thing?
Nope, because xy is x times y. I can split them apart.
2.
Because x and y would be 2 different values. What do I have to do with D? I have to take this 3xy cubed and I have to cube it. And then I have to multiply the answer by 2z to the power of 4. Three to the power of 3.
Nice.
27. X raised to the power of 3 would become x cubed. Y raised to the, or sorry, y cubed raised to the power of 3 would become
5, 9.
y to the power of 9 times 2z to the power of 4. Is there anything else I can multiply together in this statement?
The 2 and 27.
And what would I get?
54.
64. And then the variables, I generally put in alphabetical order.
Those pitch
So the questions, 1, A and H, 2, B and D, 5 and 6, 8, A, F, and H, 9A, 10, A and C, and then 11.